Hi, so today we're going to go over the 2008 FRQ problem number 6 and multiple choice 3 number 43 to 45.
Right, let's look at the FRQ first. Let f be the function given by f of x equals ln x over x for all x that's greater than 0. The derivative of f is given by f prime of x equals 1 minus ln x over x squared. So let's look at A. Write out an equation for the line tangent to the graph of f at x equals e squared. So to find the tangent line, we will need to find the slope. Slope at the tangent line is equal to the derivative of f of e of 2 squared, which is equal to f prime of e squared. And we can find that by plugging it in to the f prime function, and you will get negative 1 over e to the fourth. And that will be the slope of the tangent line. Then we need the coordinates of this equation. We already know the x coordinate, which is e squared, but now we need to find the y value. So you find that by plugging e squared into the f function, so you will have 2 over e squared. Now that you have x and y coordinate and the slope, you can make this into a point slope form. And then you can work this out and it will turn out to be y equals negative 1 over e to the fourth, parentheses x minus e squared, and parentheses plus 2 over e squared. And that will be your equation of the tangent line. Moving on to B. Find the x coordinate of the critical point of f. Determine whether this point is the relative minimum, relative maximum, or neither. Justify your answer. So to do this problem, so you need to find out the critical number, and the critical number is when f prime of x is equal to 0. So f prime of x is equal to 1 minus ln x over x squared, and then you can set the f prime of x equal to 0, and then you'll get x equals e. Now let's set up 0 to e and e to infinity to see if it changes signs. So you can pick a random number within these intervals and then find the y value, see if it's positive or negative, and in this case it goes from positive to negative. So we can say that f of x has a relative maximum at x equals e because f prime of x changes from positive to negative. Now let's look at C. The graph of the function f has exactly one point of inflection. Find the x coordinate of this point. To find the point of inflection, we need to find when f double prime is equal to 0. So you should find the f prime of x and find the derivative of that. So there's a hint of the quotient rule. So use the quotient rule to find that that f double prime is equal to negative 3x plus 2x times ln x all over x to the power 4. So you don't need the x to the power 4 because that won't make the equation equal to 0, so you can just take that out, and then you can see that when x equals 0 and when x is equal to e to the power of 3 over 2, it is equal to 0. So these are the possible points of inflection. However, x equals 0 cannot be the point of inflection because it does not exist in f of x. So you can check if it changes sign at e to the power of 3 over 2, and it does, and you can say that f of x has a point of inflection at x equals e to the power of 3 over 2 because f double prime changes sign, therefore f of x changes sign. Find limit as x approaches 0 positive f of x. So to do this last problem, you need to know the graph of this equation. So as ln approaches 0 positive, if you see the graph of it, anything that's less than 1 that approaches negative infinity. So that's negative infinity, and the denominator is basically just a very small positive number. So this very small positive number doesn't affect the negative infinity, so the answer is just negative infinity.
So let's go on the multiple choice. 43 asks the integral of x times f of x dx equals what? So to do this problem, we'll need to learn integration by parts. What is this? Basically, there's a formula that states the integral of u times v prime of d of x equals u times v minus the integral of u prime times v dx. And one has to be differentiable, one has to be indifferentiable. Let's apply this formula to the question. So since we know it's asking for the integral of x times f of x dx, we can set u as f of x and v prime as x because this works. And we can use calculus to find out that u prime equals f prime of x, and v equals x squared over 2. And we'll need these because we need these to plug into the formula to find the answer. So when we plug it in, we find that the integral of x times f of x dx equals x squared over 2 times f of x minus the integral of f prime of x equals x squared over 2. Except the thing is, this is nowhere in the answer. There is nothing here that matches this answer that we found. Which means we have to rewrite our answer or simplify it. And when we do that, we find that the answer is x squared over 2 times f of x equals minus the integral of x squared over 2 times f prime of x dx, which is answer choice B. Question 44 asks, what is the minimum value of f of x equals x times ln x? So let's move this aside and look at our work. So first, to find the minimum value of f of x, we'll need to find critical values or critical points of the function and compare them. What are critical points? There are places where f prime of x equals 0. So before we find the critical points, we have to find f prime of x, which is the derivative of f of x. Since we know f of x equals x times ln x, f prime of x equals x times the derivative of ln x plus ln x times the derivative of x. This is basically the product rule we learned in previous chapters. When we simplify this, we get 1 plus ln x. Now, to find critical values, we have to set this equal to 0. When we do that, we find that 1 plus ln x equals 0, ln x equals negative 1, and x equals e to the negative 1 power. Then we test these points. We know the range of the function is 0 to infinity, so the boundaries are 0, and there is only one boundary, which is 0. And then we plug in our critical value into f of x, and our critical value is e to the negative 1 power. So when we plug these both into f of x, we get 0 and negative e to the negative 1. And negative e to the negative 1 is the lower number, the lower value. So that means x equals e negative 1 is a location for absolute minimum. So we can rewrite that as negative 1 over e, which is answer choice C. Question 45. If Newton's method is used to approximate the real root of x cubed plus x minus 1 equals 0, then the first approximation of x of 1 equals 1 will lead to a third approximation of x of 3 equals what? So let's start. What even is Newton's method? So Newton's method is used to find real roots of functions. Basically, there's a formula that summarizes this. X of n plus 1 equals x of n minus f of x of n divided by f prime of x of n. And in the question, we know that f of x equals x cubed plus x minus 1. So using calculus, we can derive it to find that f prime of x equals 3x squared plus 1. The question also states that x of 1 equals 1, and we are told to find x of 3. So to do this, we'll first need to find x of 2. X of 2 is basically x of 1 plus 1. And since we know x of 1 equals 1, we can plug this in to find out x of 2 is 1 minus 1/4, which is 3/4. Now we have x of 2, so we can plug that in to find x of 3. Let's plug that in back into the blue equation above. When we do that, we can find x of 3 equals x of 2 plus 1, which is 3/4 minus 11 over 64, divided by 43 over 16, which is 3/4 minus 11 over 172, which is 0.686. And this is answer choice B. A calculator is required for this problem, so learn how to use it.
Let's move on to similar types of problems. Let's look at number 9 from page 295. f of x equals 2x cubed plus 3x squared minus 36x. A. Find the intervals of which f is increasing or decreasing. So do this by finding f prime of x and finding the Cn by setting f prime of x equal to 0. Then let's move on to B. It is similar to MC3 number 44 and FRQ 2008 number 6b. Find the local maximum or minimum values of f. Do this by finding the Cn and seeing if it changes from positive to negative or negative to positive. Then let's go to C. Find the intervals of concavity and the inflection points. This is similar to number 6c. So find the f double prime by finding the derivative of f prime of x, find the possible points of inflection, then find the points of inflection by seeing the changes of signs in f double prime.
Similar types of problems. The link is included above. Number 1. Find the integral of 4x times cosine of 2 minus 3x dx. So first we want to pick our u and v prime. This is basically like the integration by parts question that we found in multiple choice 3 number 43. And after we find u and v prime, we can find u prime and v. And we can plug that all into the formula listed below, and that's it. Moving on. There's another question from the same website but a different page. Number 2. Use Newton's method to determine x of 2 given x of 0. f of x equals x times cosine x minus x squared, and x of 0 is 1. The formula for Newton's method is x of n plus 1 equals x of n minus f of x of n divided by f prime of x of n. Derive f of x to find f prime of x and plug things in, and that's it. Then we can find x of 1 given x of 0 and then x of 2 given x of 1. That's all.